You've just clicked on a video about turning a sort of square block into a more square block. Just saying. Before we take this over to the mill, and I'll be squaring this in the mill, though what we'll be doing is applicable to any machine really. It's more a philosophy than a milling technique. Let's talk about what square means. What is square? And does it also imply being flat? Does square perhaps mean being perpendicular? Yes, it does. It's literally the definition of... Now, this isn't technically square. It is sharp though. Dang, it might look pretty close, but it's right off my saw. Now, typically you want to do this as fast as possible, the least number of steps. It's not that big deal for a home gamer, but you probably want to get to making your part instead of setting up your stock. In this universe, blocks have 6 sides, so 6 strategically executed cuts should bring this into square. Now, depending just how square you need it, sort of depending on your machine and how sloppy you are, it might take 7 or 8. Like you do 6, it looks square, you check it on the surface plate, you find a face or two that's out of whack, and you've got to recut it. Generally speaking, 6 cuts should do it. Basically like the 5-point palm exploding heart technique with another point. Or a face, technically.
Alright, my wife just stepped out. I grabbed her little GoPro. We'll get the shot and get this back. It'll be like nothing ever happened.
Oh, that was not good. I'm not even sure where it went. Did it go behind the lathe? I might be able to reach it with a broomstick.
Welcome back to the shop.
Now, this wouldn't be a This Old Tony flick if I just cut right to the chase. So before we actually do anything to the block, let's talk about tramming the mill. This is what a trammed head looks like. This is what a not trammed head looks like. Tramming a mill means ensuring that the head, or the axis of the spindle, is perpendicular to the table. And hopefully by extension, perpendicular to your vise, but that's not always the case. And you can bet your bottom dollar, we'll get into that in a minute. Now, because it's the axis of the spindle needing to be perpendicular to sort of the plane, the top surface of the table, that means there's 2 directions we need to worry about. Usually that's called tilt, left and right, as you're looking at the machine, and nod, sort of forward and back. Some machines you can adjust both on, some you can adjust neither. On mine, for example, I can only adjust the tilt. Now, if you have a fixed head and you can't adjust the tilt or the nod, that doesn't necessarily mean that your head is trammed. Again, in my case, I can check the tilt and adjust it, but I really can't do much about the nod. On a milling machine, that isn't always true. Man, these basics videos are just the hardest ones to do. But for our purposes, the head's got to be trammed to the table, and you need a square vise. Think of it like a table saw. If your blade's not square, or your sled isn't straight, you're not going to get a square cut. And what we need to do here is make sure the sled is straight and the blade is square. So just for kicks, let's see what happens if your head's not trammed in. If your head's not square to your work. Now this obviously is exaggerated. Usually if it's out of tram, it's just a couple of thou, if you're lucky. This is at about 15 degrees and it's just to illustrate the point. Now I think everybody can agree that if I move this in this direction, I'm going to end up with that angle on this workpiece. I'm going to end up cutting a 15-degree chamfer there. That's how you would set up such a cut. So I'm not going to make that cut. I think that's self-evident. If I cut it 15 degrees, it's not going to be 90 degrees. Now let's cut the other direction with an out-of-tram head and see what happens. If your head's not trammed, it's going to be a little trickier to make flat and square parts. Now there are a couple of different ways to tram your mill. I just use an indicator on 2 parallels. I managed to get this within a thou without too much trouble. It doesn't always go so smooth. I'm traming over parallels that are about 14 inches across, 13.5, 14 inches. Since my part is approximately 2 inches, that should turn out to be 7 times less the error that I see on the indicator. It's called 2/10. Now that's the error between the axis of my spindle and the top of the table. And now we introduce the vise. Where do I even start with these things? Anything we introduce between the work and the machine is a potential source of error. Now we tram the head to the machine, but we're not putting the work on the table, we're putting it in the vise. Arguably the 2 most important features of a vise, other than its ability to hold on to a part and not let it go while you're trying to do something, is that the bottom be flat and parallel to the machine, and that the fixed jaw be square. In squaring your stock, and pretty much any operation you do on the mill, the squareness is dictated by that jaw, assuming you're working in a vise. The fixed jaw ought to be your best friend. Now typically a higher quality vise is more reliable. You could trust it to be flat and square and repeatable. You should always check, but that's usually the case. That's not to say you can't do good work in a low quality vise. It just puts more onus on you, the operator, to check what you're doing is going the way that you expect it to. Now since I'm mounting this vise, I'm going to go to the trouble to indicate that fixed jaw into the x-axis of the machine. That means put it parallel with the left-right movement of the table. Now, technically to square a block up, that's not necessary. It might be weird not to, but it's not necessary. If this fixed jaw is square to the table, it's going to be square to the table any way you put this vise. Now we can start to square this thing up. And if you ask me, it's about time. You'll want to start off with the largest face. If you think you know why, leave a comment down below. Since this is a cube, it doesn't really matter where I start. This happens to have 5 sawn sides and 1 mill finish side. I'm going to start with this one up against the back jaw. And really for no particular reason than that face is probably more consistent than any of my saw cuts. The vise is supporting the workpiece on 3 sides, the 2 jaws and the bottom. The 2 jaws, however, are the only 2 that exert any force on the block. They're the ones squeezing and holding on to the thing. Because we have 2 non-parallel faces up against another 2 faces, these 2 jaws will be sort of vying for power. We said we trust that fixed jaw, so we want to take this movable jaw sort of out of the equation. In order to do that, we introduce something between the movable jaw and the work that is either compliant, like this little aluminum welding rod, or has a small surface contact, a little dowel pin, or a ball bearing. So that's what the ball bearing would look like. It's in there nice and solid. It shouldn't move under cutting forces. Anyway, since this is soft material, I'm just going to use some aluminum TIG rod to keep from marking up these surfaces. Doesn't really matter now, but as we start machining them, I'd rather not have a big dimple pushed into each side. Hopefully we're confident now that we're pushing the work up against that square fixed jaw. Since we're being all clinical about this, let's have a look at the bottom. Now I don't know if you'll be able to see this. The bottom of this block isn't square with the back of the block. There's a little bit more of a gap here, and it's touching the base of the vise back in this corner. The way this is set up, with this less than 90-degree angle back towards the fixed jaw, with a gap away from that fixed jaw, we could cut this if we wanted. We could leave your friends behind, because your friends don't. If the block were the other way and the larger angle was back here, you could get into a situation where you're camming your block in the vise, sort of fighting the back surface, the bottom surface, and the out of squareness of your part. To avoid that guesswork, you can put the block up on a single parallel. Generally, if you have a non-machined surface on the bottom of your vise, you'll want to put it up on a parallel. Now we just tap it down a bit, firm up the vise, and we can take that first cut. Speaking of tightening the vise, you don't need to go crazy here. This isn't an A-bomb torque kind of situation. These aren't the lug nuts on your car. Over-tightening could lead to other inaccuracies. In particular, it could accentuate jaw lift. That's the lifting of the movable jaw when you clamp work in it. If you haven't seen it, check out a video called Machineshop Physics. Squeeze it just enough that you know you're holding your part securely. We're not trying to achieve nuclear fusion in the home shop here. Not yet, anyway. We'll give this a quick deburr, and we'll be ready to move on to side 2. Now I happen to do this with a face mill. You obviously could do this with whatever you wanted. An end mill, maybe a fly cutter. I was able to do this in one pass. My block is the same size as that face mill. How serendipitous. Okay, so we have one machine side. For the purpose of this video, I'm going to label them just so we can keep track of them. I'll call this side Laverne. Make sure the vise is clean. And we'll put that first machine side up against the fixed jaw. Give it a little nudge. We can cut the second face. I didn't quite get it all, so I'm taking a second pass. And we'll call this side Shirley. So at this point we've made 2 cuts, and it's probably a good idea to make sure Laverne and Shirley are square with each other. If not, that could result in some zany misadventures. So my favorite small square is this die maker square. Now I don't want anybody out there accusing me of funny business. A die maker square you can basically tune in and out of square. Like you could set this to 2, 3, 4, 5 degrees off of square. You'd want to do these checks on a surface plate. But that's nice and solid in there. It's good and square. No rocking, no gaps. And no, that's not my gag 1 degree right angle plate. Now we have 2 machine sides. We can take the parallel out. Again, make sure everything is very, very clean. Doesn't take much to knock you out of square. Put 1 machine side down and 1 machine side up against the fixed jaw. Still using the little aluminum rod. So we've got Laverne, which was our original reference face. Shirley, opposite Shirley would be Squiggy, of course. So we've got S and S prime. Now that should be square. And these 2 sides now should be parallel. Since these are now opposing machine surfaces, this is the time when you would have taken this to size. So this may have been a skim cut. And this is maybe a roughing and a finishing cut to get you, close to the dimension you need to be. Let's index it 1 more side and hit this rough sawn face. In these videos you may notice that I usually cut from right to left. When there's no camera here, I cut in every direction. Cutting from right to left just keeps the chips flying back and away from the camera. And that brings Lenny into spec. One wolf. Alright, so we've got the 4 easy sides machined square. All that's left now are the 2 tougher nuts to crack, Carmine and Frank. And as much as I hate to be the bearer of bad news, let me lay the problem on you. Every cut we've made so far has resulted in a face that was perpendicular to the last one, or perpendicular to the fixed jaw. In cutting these last 2 sides, really just one side, that 5th cut is the tricky one. Once this is done, the other one will sort of fall in place. Once you break Frank, the big ragu will fall in line. Anyway, this cut needs to be square to that back face, but it also needs to be square to a side face. We need to create like a right corner. Is that even a word? What's the 3D equivalent of a right angle? With 1 cut, we've got to be perpendicular to 2 surfaces. As I've been trying to drill into you guys, any cut that you make with this setup will result in a face perpendicular to that fixed jaw. So if we put this block up at 20 degrees, face the top off, that top will be perpendicular to the back, or to whatever face is up against that fixed jaw. Obviously, it wouldn't be perpendicular to this face that's up at 20 degrees. So we need another reference to set this face up. The usual way to do this would be to use a square. Set the square up in the bottom of your vise or on a parallel and make sure your block's lined up. You could also use a V block, a 1, 2, 3 block, or a picture of Huey Lewis. Anything that you're confident is square. As I'd like this thing to be hecka square, I'm going to use a dial indicator. I'm going to move the work up and down, sweeping that face with the indicator, and tapping the block until I get as close to 0 run out as possible. No motion on the indicator will mean that that surface will be square to the cut I'm about to take. And then just like before, we'll take a cut or 2, get it down to size perhaps, and then deburr it. And now we can bring in the last side. We have machined faces everywhere else, so we can just put this right in the vise. Little tap's never a bad idea. And we can clean up the sixth and last side. Welcome to my surface plate, a place in my shop where dreams come to die. Before we get into how this turned out, let's talk about squareness and parallelism. Measuring and surface plate work could probably take up an entire video on its own, but allow me just a moment to do it a disservice, just so we're all talking the same language. Squareness and parallelism are like kissing cousins. It can be simple and complicated all at the same time. Let's start with this shape here. Not coincidentally, you can tell just by looking at it that it's not square. If you know the name of this shape, leave a comment down below. So let's assume our block looked like this shape. If you were to measure with a micrometer or sweep it on the surface plate, you'd find that each set of opposite faces is parallel. No matter how you turn it, you always get the same measurement. The moral of the story? If something checks out as parallel, it doesn't necessarily imply that it's square. That was fun. Now let's do this shape. This is similar to the last one, except now one of the two angles is square. If you were to take a mic or an indicator reading here, you'd find that at least one of the two sets of faces isn't parallel. And it doesn't matter which way you flip it, it's still the same shape. It's still the same problem. In this case, two different readings mean that at least one of the angles is out of square. So before, when our block was measuring parallel, that didn't necessarily mean that the block was square. But if it doesn't measure parallel, it most certainly means that at least one of the corners, at least one of the angles, is not square. Our job is to figure out which one of those, or which combination of those situations, we've got going on with our block. And if we can't, we might have to find a new job. I've got a half-thou indicator mounted in a heavy surface gauge, and I'm going to be sweeping the block underneath it. We'll take a look from the top so you're seeing what I'm seeing. Make sure to actually hit record on the camera and zero the indicator. I just did this, and the surface is within a thou. It's about 0, 1, 1, half a thou. Let's check another side. Now right off the bat, you can see this side is 5 thou higher than the last side. It's actually 6 thou higher. And within a thou across the square dimensions, and 2 thou from corner to corner. Let's check the last set of faces. That's like 1 1/4, not quite 1 1/2. Quick recap. We've got two sets of faces that look promising. Like we said before, they're more or less parallel, but we still don't know if they're square to each other. I may get some heat for this, but off a milling machine, 1 thou on this side part, I don't consider that all too bad. Could probably do better, half a thou, if you were very careful on each side, maybe didn't do this in a vise, or did it in a better vise. But if you're looking for tenths of a thousandth, the milling machine usually isn't the place to get that. Anyway, two promising sides, and one side that's just completely out of whack. Now there are two things we still don't know. If these sides are square to each other, and on this crazy side, which one of these two faces is causing the problem, right? When we took these measurements, it's a comparison between this face and this face. At any rate, we have at least one side to fix. How serendipitous. For checking the squareness, I've moved my indicator over to a surface gauge that has a bumper on it. And I've zeroed the indicator using a known square. Let's start off with the faces that measured parallel. So that looks like about a thou leaning in towards the indicator. So if we turn this around, it better say about a thou or half a thou leaning the other way. We know that had to happen because of the parallel numbers we measured earlier. Let's try the other direction now. Again, about a thou leaning in towards the indicator. If I turn this around, we should get just the opposite. Within a half a thou error. There we go. It's a little bit more than 1/10. Our deviation was 1/10, so plus or minus half 1/10 will affect that squareness measurement. For argument's sake, let's call those two sets of faces good. Let's find out which two of these faces was the patsy, the troublemaker. So that's within 1/10. That's half 1/10. There's 2/10. And there's 1/10. Let's try the opposing face. 1/10. So that's 0, and its opposing side is 2/10. This is the face we have the most problems with. So I suppose we can wrap this up by having a quick look at how you'd sort something like this out. Now I'm just going to take relative measurements here. I'm not worried about that 6/10 difference we saw, because really it shouldn't have been a surprise at the surface plate. You would have probably been keeping track of your nominal dimensions at the milling machine while you were cutting this thing. Alright, so that's actually 1/10 worse than before. There really was some sloppy measurement. It's actually 1. Let's take it back to the milling machine. So there's really no end to the things that could have actually caused this to go so far out of whack. I mean, we said the mill tram over this distance was only a couple of tenths at worst. I mean, it all adds up, but that's certainly not what caused this big of a deviation. There could have been a chip back here, just general sloppiness. There was a bit of an error. I don't remember which side face this was, but there was a bit of an error when I indicated in the squareness of the offside. I mean, it's hard to say. Maybe a 1.5 shim got stuck back there inadvertently. Now, you could just be more careful in setting this up. Close your eyes, grit your teeth, and take another cut off the top. Hope things go better. But usually when you're at this point, you don't have that much material left to gamble with. The thing to do is set the surface back up with an indicator. And what we want to do is use the indicator to recreate the numbers we measured on the surface plate. Let me set it up and I'll show you what I'm talking about. Alright, so that kind of backfired. I don't know if you could read that, but my indicator was reading exactly those same numbers. So I zeroed at the front, and it's telling me 1/10 here, a hair over 3/10 there, 3.5. That could be tweaked in a bit, and about 2/10 there. So that's the lowest corner, that's the highest corner. That means if I take this cut, it's going to clean that side up. It's going to take that error out. Unfortunately, that's a result of how I managed to contrive this situation. Let me take another shot at this with the two legitimate sides. If you look closely, the error pattern is the same. We've got a low side and a high side, a low side and a high side. That says to me that it's something inherent in the setup. It's either the tram of the machine or maybe it's the vise. I'm sure if we were to measure the top now, we'd probably get the same thing. Let's take a look at how you'd fix this. Now, depending how accurate you want this really just becomes an exercise in indicating. But what I would do is put the high side back by the fixed jaw and shim it. This is probably a little bit thick. It's just the note paper I had around. But you want to use like, I don't know, either shim stock, but something softer is better. Like a cigarette paper, depending how much area you're trying to take out. Clamp that in your vise and run the indicator back and forth until your high side actually shows up high. So this side would be 1/10 higher now because we shimmed the back. We've turned the block a little bit. And this side stays low. So when you take the cut, you'll be cutting more in the back, hopefully 1/10 more in the back, and next to nothing up at the front. In this case, you could try to tap it in to pick this 1/2 side up a little higher, but I think this is just noise in the setup. You're starting to get down to the limits of what a milling machine will be able to do. I'm not going to go into that because that's going to make this video an hour long, but hopefully you follow that logic. We're using a shim to make up for some error in the setup, taking the cut and checking again. One important thing not to lose sight of, however, is that this might not be the bad side. Just like before, you'd want to check if it was this face or its opposite face on the bottom in this case that was causing these problematic readings. But now that that last face that has been fixed, problem child we saw on the surface plate, this block should suffice for what I needed to do. Anyway, I know that was a little bit on the long side, but hopefully you found that interesting.